And we are back live. Okay. Oh no, I saw that. Oh goodness. How could his rear end step on it? And that yeah, I don't know. Yeah. Okay, so first of all, for those of you that are online, if you'd be so kind as to leave a comment, I do have the chat open on my phone. I'll be able to see that in a little bit. But first, I just wanted to remind you of the dates. I'm turning the camera to face the calendar. I've been going over this multiple times, but I just want you to know how close we are. We are closer than ever before, clearly. This week, I have you on Tuesday and Thursday. Today, we will be wrapping up sequences in series. I do have assessments that I am going to be assigning you next class period in regards to sequences and series, arithmetic and geometric. But we'll talk about that when the time comes. But we will be wrapping that up today. Obviously, you do have the quote-unquote intervention period at noon. I'm not going to be assigning anything brand new today for the intervention period, but I will be allowing the use of that time to make up things because there are a lot of things that you potentially owe me, but we will talk about that when we get there. But today we're going to be wrapping up sequences and series. On Thursday, full class period, I have two things on the agenda for Thursday. Number one, I'm going to be assigning you some of the assessments, or the assessment, I should say, that I have for sequences and series. And then on Thursday, we will be beginning our final exam review. Let that wash over you. Okay, nobody cares. All right. And then next week, weird week, I have you on that Monday. Even though it is senior exams, I still have you on that Monday in which we will continue reviewing for the final exam. Then I have you on that Wednesday, which is a 60-minute class period, in which we will wrap up our final exam review. And then I have you again on that Friday, the 11th, in which that is the day that we will take our final exam. Speaking of computers, just as the side note, because, broken whatnot, but you obviously need your Chromebook for Friday the 11th for those of you that are here in order to take that final exam. And then after that, I won't see the seniors again, but the following week on the 17th, I will have you for that. How long are the exam periods? Like 2 hours? Something like that? Yeah. Yeah. What's up? No, I know. No, I know, but we are 10 days away. So in those 10 days, we got to figure out a solution. Well, the screen is a bit, I saw it very briefly, but it's very, it's hard to get around it. Yeah. I think my brother did that for his too. No, but between now and Friday the 11th, you absolutely have to get in contact with the IT department. I assumed they would replace it. I assumed that they would replace it. Yeah, and they would take the old one and try to salvage whatever parts they could, But definitely between now and the 11th, you got to get that taken care of. But anyway, So, for those of you, just as a reminder, even though, yes, on Thursday the 17th, I'll have you for 2 hours or some junk like that. Obviously, we're not doing anything unless you owe me something. But I'm not officially doing anything on that day. Ms. Markey, do we have to be here? If you're not a senior, yes. Otherwise, I will mark you absent. So I'm going to take regular attendance that day. But seniors will be excused, obviously. And then on Friday the 18th, we'll have that weird day where, again, I don't see the point, but we're here that day. Nobody wants to see their teachers for the school. Yeah. Well, it is a magical place. It is. You don't even know. Oh, goodness. Even still, that'll be the rest of your life. Because pretty much you'll be in your 20s and 30s and 40s, and you'll be like, man, there's a lot of stuff I don't remember.
I don't even remember like simple things from elementary school. I phased it all out.
Nah, you still know how to walk though. There you go. Anyway, ladies and gentlemen, my goal, again, like I said, is to get to that time of the intervention period, which will be at noon. Until then, I want to finish up what we're doing with sequences and series. So if you would, if you do not already have them out, I'm going to need those notebooks out and open. I want you to savor that moment, because that might be the last time you hear me say that.
Wow, that's honestly super exciting.
Okay, let's see here. Like I said in the live chat, I do have this open at my desk. It wouldn't load on my computer again for some reason, but I got this here for you. I'll bring this screen over. And like I said, we're going to wrap this thing up. Now, and this was a while ago. Last time I had you was Tuesday of last week, correct? Man, Tuesday of last week. Tuesday of last week, I gave you this particular worksheet. I am going to be picking off problems off of the 11.3 side of this worksheet. So please be aware of that. For those of you online, I believe, and I'll show you this visually, on Tuesday of last week, I believe I did post, there it is right there, this worksheet. So it should be available to you, and I will be working off of the 11.3 side of that worksheet. So everything is available to you online. Let's bring this thing here and here. Let's get this thing moving here. Here we go. Today is June 1st. My word. This is the home stretch. We're not at the finish line just yet, but you can see that finish line. Goodness gracious. And I'm calling this geometric sequences and series. I have already introduced to you various aspects of geometric sequences and series. I have given you some formulas in the past, but today I'm really going to dig deep on geometric sequences and series. Last class on Tuesday, that distant time of 1 week ago, I focused most of my attention on arithmetic sequences and series. We focused most of our attention on that, and now I just want to wrap up with geometric sequences and series. Obviously, like I said, on Thursday, I will be giving you an assessment in regards to all of the sequences and series that we've been doing. So obviously, we need to be ready for that. On the 11.3 side of this worksheet, I am writing down problem number 5. Now, problem number 5 gives you the following pieces of information. They say 6, negative 24, positive 96, negative 384. And they ask you a very straightforward question, but I'm going to expand upon that question. I'm going to take it a little bit farther. But the simple directions on number 5, all that they're asking you to do is to find the common ratio. Now, last Tuesday, when we covered arithmetic sequence series, as a reminder, were when the pattern was add or subtract the same number every single time. That was arithmetic. Arithmetic sequences were when you added or subtracted the same number every single time. But in this case, geometric, it is no longer adding and subtracting, it is multiplying and dividing. And it shouldn't take that much time. Maybe it will take you a few extra moments, but it shouldn't take that much time to realize what that common ratio is, what that number is that is being multiplied or divided every single time. going back and forth between a positive and a negative and a positive and a negative. It goes from 6 to negative 24 all the way up to 96. I mean, it really shouldn't take that much to realize that your common ratio is negative 4. It's being multiplied by negative 4 every single time. Yay, we did it. Cool, great, wonderful. Now, if I asked you, hey, what is the fifth term in this sequence, you would just be like, well, Mr. Mark, you just take negative 384 and multiply it by negative 4. And I'll bring my calculator over to kind of show that. There it is right there, zooming in. So the fifth term would just be a positive 1,536. Yay. What if I didn't want the fifth term? What if I wanted the 500th term? If I wanted the 500th term, again, you can't just be like, all right, well, I guess I'm going to be doing this 500 times. No, I don't feel like doing that. Instead, we focus on this general rule. Now, we've written down this general rule before. I want to write down this general rule again. This general rule is very similar to that of arithmetic sequences and series. Very similar. It still has that first term, a sub 1. But instead of multiplication, instead of addition, it's a multiplication within that formula. Instead of that n minus 1 being in parentheses, being multiplied by something, that n minus 1 is now being raised to an exponent. Wonderful. But this is the general rule for a geometric sequence. All I have to do is plug in the first term, the common ratio, and I have it. There's nothing to simplify. There is nothing to simplify in that formula. You can't simplify. Some people might want to take that 6 and multiply it by that negative 4, but I'm telling you, no, don't do that. You're not allowed. You cannot, because you have to evaluate the exponent first, then multiply whatever that result is by positive 6. That would result in the term you're looking for. So, for example, we already know what the fifth term is, but I'm just going to try and find it right here. I mean, I did it in the calculator earlier. If I want to find that fifth term, I just simply have to plug this information in, make sure that it is simplified correctly. The 5 goes into the exponent. I have to do 5 minus 1 first. So it really should be 6 times negative 4 to the 4th power, which, if done correctly, the calculator does indeed say 1,536. Now, I would say that's not what the question was really asking. The question just wanted the common ratio, but these questions can potentially ask you anything. They can potentially ask you anything. So, I want to do another one right here. I want to do another one on that page. If you have that page, you can copy this down, but I'll copy it down as well. I want to do number 8. Number 8 is going to take it a bit farther. Number 8 is going to take it a bit more to the extreme. But number 8 is asking pretty much the same question. And I want to show you some fancy work in the calculator once we get there, because this problem does require a bit of fancy work and a bit of understanding. So I'll zoom in right there. There's number 8. Number 8 gives you all of these fancy fractions. And you can, just using a bit of common sense, you can figure out what the pattern is. You absolutely can, just with a bit of common sense and intuition. Absolutely. No harm, no foul. Now, these fractions are a bit messed up, but you tell me, what am I going to put down for the common ratio? What the heck am I going to write for that R value? Yeah. What am I going to write for this R value? Now, again, it tells you that it's geometric. It tells you it's geometric, meaning that there is a common ratio that's being multiplied every single time. These fractions are kind of messed up, but you have to recognize the relationship. Look at the numerators. Now, I'm ignoring the 1 for now. I'll skip the 1, but look at the numerators. When it goes to 4, to 16, to 64. Look at the denominators, going from 9 to 81 to 729. Again, sometimes it takes a bit of intuition, common sense, logic. But if I go to the calculator, I can figure something out about the numerator and about the denominator. Move the calculator over here. To get from 4 to 16, clearly it's just times 4. If I times it by 4 again, I get 64. Fantastic. It seems like the numerator is being multiplied by 4 every single time. Look at the denominators. The denominators go from 9 to 81. I mean, clearly 9 times 9 gets me 81, but if I multiply it by 9 again, you do get 729. This is where that little bit of intuition happens. You can figure out that the common ratio is the fraction 4 over 9. It just so happens to match one of the terms in the sequence, yes, but the common ratio is indeed 4 over 9. Now, according to the problem, they want me to do 2 things. They want me to write a rule for the nth term, and then they want me to find the 8th term. I'm going to do both. The 8th term is going to be a little tricky. If I want to find that rule, I'm going to use that general rule from before. A sub n equals my first term, which in this case is just 1, so I'm just going to put that 1 there, times my common ratio to the n minus 1 power. There's nothing to simplify. You don't have to worry about simplifying that thing. But that is the general rule. You run into a little bit of issue with the 8th term. You run into an issue that, well, once I show you how to actually trick the problem into giving you the answer, it makes sense. But not a lot of people figure this out at the beginning. Check this out. I'm going to show you something. To find the 8th term, I'm simply going to plug an 8 into that equation. And because the exponent is n minus 1, I'm going to have to evaluate that fraction to the 7th power. But watch what happens here. Watch what happens here, because this is ridiculous. If I actually do this correctly, I get this decimal for my 8th term. But the problem is I'm not going to write that down. I am not going to put that decimal down as my answer. I don't want that decimal as my answer. I want a fraction, a simplified fraction. Now, there is actually a nice little function in the calculator that can turn decimals back into fractions. And some of you have used this before, and that's perfectly fine. However, again, you run into a brick wall. Because if I try to turn this decimal back into a fraction, the calculator won't do it because the calculator can't do it. The calculator doesn't have enough memory to display the actual answer to this problem. It's a little bit of a trick that you can do to get this answer, but the calculator, unfortunately, has reached its limit. Can't do it. This is where you must rely on logic. This is where you must rely on intuition and common sense. The calculator won't do it. Oh, I guess I'm done. No. Instead, rely on what you recognized at the beginning, where the numerator was being multiplied by 4 and the denominator was being multiplied by 9. Rely on that intuition. And then instead of trying to type this thing in as I have up here, not being able to get the answer, instead, you do something like this. In order to get the actual eighth term of this problem. The actual eighth term is this messed up looking fraction that the calculator, unfortunately, is not able to display. I took a class in college called Real Analysis. I'm not going to bore you with the details, but there was an extra credit problem. There was an extra credit problem in which the guy gave us a fraction and he said, okay, in order to get the correct answer, you have to figure out how many decimals that this fraction will calculate before it begins repeating. What I mean by that is, like, usually fractions either terminate or they repeat. They either terminate or repeat. Like 1 divided by 4 terminates. It just ends. Whereas 1 divided by 3 repeats. It goes on forever. 1 divided by 7 repeats. It goes on forever. But 1 divided by 7 repeats after 1, 2, 3, 4, 5, 6 digits. And then it repeats forever. So my professor gave us this fraction and he said, okay, figure out how many decimals it takes to repeat. And if you tried using a calculator, it wouldn't work because the calculator only has, oh, someone get that door? Oh, okay, all right. The calculator only has a finite amount of information and it could only give us up to like maybe 12 to 15 digits or something along those lines. I don't think anyone in the class legitimately got it, but the answer was like 120 or something like that. It wouldn't repeat for like 120 decimals. It was messed up. Maddie, I'll briefly catch you up on something I did in the calculator. You ready? Okay. We just did number 8, and I got all this information here. But then the problem wanted me to find the 8th term. The problem was, if I type all this junk into the calculator, it doesn't give me the 8th term. It gives me a really messed up decimal, which I don't want. But the calculator actually has a function that can turn it back into a fraction, but the calculator can't do it. Ugh. So what does one do? How did I get this? What I circled here. Because the calculator wasn't able to really do it for me. This is where a bit of intuition comes into play. If you go back to the original sequence, the top of the fraction is being multiplied by 4, and the bottom of the fraction is being multiplied by 9. As a result, instead of doing this calculation, just like we can intuitively figure out the pattern, calculate the numerator and the denominator separately. And by doing so, it actually gives me the fraction that I wanted, which is weird. That's just a bit of weird math, but I like it. Okay. Here's what I want you to do. I am going to give you a little bit of time right now to do, well, 3 problems. 2 problems, definitely. 2 problems that you can absolutely handle. 2 problems that I definitely believe that you should be perfectly fine with. And then 1 problem that is a small challenge. So I'm going to give you these 3 problems. I'm going to tell you, hey, definitely get the first 2 done. Definitely get the first 2 done. If you think you can handle the 3rd problem, by all means, go for it. But if the 3rd problem does give you some difficulty and you're like, I don't know about this one, that's fine too, because this is a small challenge. I would like you to complete numbers 6, 9, and 12 off of that worksheet. Now, I am going to give you a little suggestion on each of them per se. I'm going to write those down in a moment. Hold on. But I am going to have you do number 6, 9, and 12. Number 6 and 9, you should be able to handle very easily. Number 12 is small challenge. Number 12 is a small challenge. On number 6, they give you the following pieces of information. They say, okay, here you go. It's 1/3, 2/9, 4/27, 8/81, ... And on number 6, they just want the common ratio. That's all they want. They just want you to find the common ratio and move on to the next problem. Like I said, you should be able to handle number 6, no worries. Number 9 does require a little bit more. Number 9 gives you the following. That's a positive. Gives you the following: 2, -8, 32, and -128. And they want the general rule, and they want you to find the 8th term. They want the general rule, and they want the 8th term of this particular sequence. And like I said, number 12 is a small challenge. Number 12 is a small challenge. Number 12, they want the general rule, but they only give you these 2 pieces of information. They only give you the 3rd term and the 6th term, and nothing else. They give you the 3rd term, which is 8, and the 6th term, which is -64. If you can handle number 6 and 9, you're good. You're fine. You've got this. Number 12 is a small challenge. If you want to try it, absolutely go for it. If you can't get number 12, no worries. Small challenge. I want you to take the next little block of time and knock out these problems. Let's see what you can do. Yeah.
They only want the general rule for 6 and 9.
For number 6, they just want the common ratio,
Oh,
according to the directions. What I'm trying to set you guys up for is the assessment that I have late on Thursday, because some of the problems are literally just asking for that one tiny piece of information. But some of them are asking for a bit more. Number 9 wants the general rule, and it wants the 8th term.
okay.
Yeah. All right, let's see what we got here. Now, obviously, the first couple ones have some very straightforward information. The first one, just fairly straightforward, is just the ratio 2/3. That one should literally not have taken that much time at all. Just realizing again that the top of the fraction is being multiplied by 2 and the bottom of the fraction is being multiplied by 3. Very straightforward. Number 9, on the other hand, not exactly as straightforward because they are asking for multiple things. On number 9, they are asking for that general rule. Now, in this case, first we do have to identify that common ratio, which is being multiplied by -4. Don't lose sight of the fact that it's going back and forth. Someone get that real quick? Okay, all right, cool. It's being multiplied by -4. It is going back and forth between a positive and a negative and a positive and a negative. No big deal. In order to find the general rule, we would have to identify also the first term, which is, again, fairly straightforward. Just the first term is +2. But then here is my general rule, 2 parentheses -4 to the n minus 1 power. This is my general rule. Do not make that a -8. Do not multiply them and make a -8. They have to stay separated. You have to evaluate the -4 to the exponent first, then multiply by 2. Now, in order to do that, well, we have to find the 8th term. The 8th term is just a matter of plugging in the proper information. And now, instead of raising it to the n minus 1 power, I'm raising it to the positive 7th power. Going to go to my calculator and get that particular portion done. 2 parentheses -4 to the 7th just spits out a -32,768. It is going to go back and forth between positive and negative numbers. In fact, you can even see the first, third, and probably 5th number are all positive, meaning the 2nd, the 4th, the 6th, and the 8th are going to be negative. It's going to go back and forth and back and forth. Now, number 12, I did say was a bit of a challenge. If you could handle numbers 6 and 9, then you're golden. Number 12, again, a bit more of a challenge. They don't give you the common ratio. They don't give you the first term. What we're left to do, again, is a bit of common sense, a bit of intuition. What I'm doing right here is I'm actually listing out what that sequence would potentially look like. First through 6th terms. They give me the 3rd term, and they give me the 6th term. And the only other piece of information that they give me is the fact that it is geometric. That's all they give me. This is why I said this problem was a bit more of a challenge. But again, if you can handle this one, you can handle any of these problems. Realizing that I'm going to have to be multiplying by a negative, because this thing is going back and forth between positive and negative. Hold on one second, I gotta sneeze. Oh, goodness gracious, thank you. Sneezing is still not fun. I spent the whole weekend with no mask, and now I'm sneezing into my mask again. Disgusting. I hope everyone at home is disgusted on the microphone. Anyway, I have to go back and forth between positives and negatives. The 3rd term is indeed a positive. Then it may go negative, positive, negative. Okay. Now I got to figure out what the heck I'm multiplying by. You could take a few guesses, and yeah, these guesses would potentially work. Let me try it with 2. 8 times -2 will give me -16 times -2, positive 32 times -2, -6. Oh, it worked. I thought it was a different number. -2 just seemed to work. Well, there we go. R is equal to -2, because if it is, then I could easily go -16, positive 32, -64. Now, in order to write the general rule, I'm going to need the first term. Again, common sense, intuition. It doesn't take that much to figure out. I got to work backwards to my first term. This has got to be a -4. This has got to be a positive 2. As a result, a sub n equals my first term times my common ratio to the n minus 1 power. That is the answer to this problem. That's all that they really wanted. They didn't want anything else other than the general rule. That is the general rule. Again, if you can handle number 12, you can handle any of these problems. But number 12 was a bit of a challenge. If you can handle 6 and 9, you're still golden. Just that 12 was, again, a bit more out there. Okay. There's just a couple more things that I have to do before we wrap this up for today, and you can get to that intervention period. Just a couple more things, and I will be done. I have to talk about a sum. I have to talk about number 16 on this particular worksheet, number 16. Number 16 gives you the following pieces of information. 1 plus -4 plus 16 plus -64 plus ... That's all they give you. We're not doing part B. We're only doing part A. Part A asks you to find the sum of the first 8 terms. Find the sum of the first 8 terms. Last week, or probably even the week before, I'm not sure when I gave it to you, but I'm going to write it down again. But I gave you a formula that looked like this. Now, obviously, for any assessment that we're having on this, you would be given this particular formula, but this formula is for the sum of a geometric series. The sum of actually a finite geometric series. I'm going to distinguish that later when I write something else down. The only things that you need in order to find the sum of a geometric series, the only things that you actually need are the first term, the common ratio, and the number of terms that you are adding up. This is a lot easier and a lot nicer than arithmetic series. A lot easier and a lot nicer. Who's in trouble now? Mike is in. Okay. Bye-bye. Maddie, they're sending you home. Maddie, they're sending you home. Just so you know, I would be wrapping up within the next 5 or so minutes. My plan was to, as I said at the beginning, use that intervention period as kind of like a chance for people to catch up on things. So you'd only be missing about 5 or so minutes. All right. Cool. And then on Thursday, we begin the journey to the final exam. The first term in this particular series is 1. You just tell by kind of looking at it. The common ratio is -4. So the common ratio is indeed -4, just because this thing is being multiplied by -4 the whole way through. And we're adding up just the first 8 terms. This is the calculation that needs to be done. The only thing that you have to worry about is knowing how to type that in correctly into the calculator. That's the only thing that you have to worry about. Nothing else. Nothing crazy, nothing out of the ordinary. Just identify what that first term is, identify what the common ratio is, and identify the number of terms being added up. If you can type that in correctly, then you have it. You just have to be very careful with how you do that. Now, what I'm going to do 2 things. Number 1, I'm going to write down what that answer actually is. And then I'm going to show you what it would look like in the calculator when you tried to type it in. That is what the answer should be. -13,107. That is what the final answer for this particular problem should be. But again, typing it in is another story. Who is in trouble now? Mr. Marcus' room. Okay. Bye-bye. Gio, go home. All right. Same deal. Like I said, I'm going to only be spending the next few minutes on this, and then the intervention period would have been an opportunity for people to catch up. Do you think you'll have an opportunity to stop at IT before the end of next week? I was talking to you for like the last 30 seconds.
sorry.
My word. Well, number one, what I said to Maddie still applies. I was only going to spend another few minutes on this, and then we were going to do the intervention period, which I was going to allow people to catch up on things. Number two, do you think you'll have an opportunity to stop at IT before the end of next week? Okay, I just wanted to make sure. Obviously, there's plenty of time, but obviously it needs to be taken care of. Yep. Anyone else getting signed out? I was going to say. Anyway, so typing this thing into the calculator. Again, you do this a number of ways. Here's one ridiculous way you could do it. This is just a way that I do it, but I'm going to show you a much easier way in a moment. I don't know who in their right mind would actually do it this way, except me. Some ridiculous. There we go. It's ridiculous. Who in their right mind would actually try to type it in that way? Nobody. Nobody. I would type it in like this if I were actually a student. What I would do is this. First, I would do the top of the fraction just by itself. The top of the fraction by itself. Then I would do the bottom of the fraction by itself. Then I would divide them, clearly. And then I would multiply it by what was out front. In this case, it was just a positive 1. Doing it that way is so much easier and so much nicer and so much more straightforward. Don't try to type the whole thing in at once. Don't be ridiculous. Instead, type it in a piece at a time. Type in the numerator, type in the denominator, and then see where it takes you, which is why I like to do it like this. In fact, you could probably even do this, divided by parentheses 1 minus -4. Yeah, you could even do it like that. But don't try to type it all at once. Don't be a hero. Okay. Finally, last thing I need you to write down. Very, very last thing I need you to write down today. Before we get to that intervention period, I need you to write down this. Finite geometric series versus infinite geometric series. Finite versus infinite. I don't know why they pronounce it finite and infinite. Why don't they call it infinite or finite? I don't know. Don't care. For a finite geometric series, this is the formula that you just wrote down before. It's the same formula, no changes, no big deal. A finite series just means that it stops. It just comes to an end. No harm, no foul. It just stops at a certain point and you add up all the terms that are there. Whereas, now this is brand new, an infinite geometric series means you're adding up an infinite number of terms. But the formula is much, much nicer. The formula is much easier to recognize and do. The general idea being that if you had an infinite geometric series, then you could add up an infinite number of terms as long as the common ratio was a number between -1 and +1. We are going to get a small bit of practice with that on Thursday before I give you this assessment that I'm going to be assigning you for a geometric series. And before we actually begin the final exam review on Thursday. It's going to be interesting. But as for now, we are going to transition into that intervention period. Now, for those of you online, I'm going to be remaining online for questions, of course. And just in case people have failed to comment, and they still need to comment in this thing. But as for right now, you have until 12:22. Ladies and gentlemen, I strongly suggest that you take advantage of this time. There are things that you owe me. There are some post-assessments that you have not done. There are some major assessments that may need some work. There are some remediation enrichment activities that may need to get done. Check Google Classroom. See what you owe me. You have the time until 12:22 to get this thing done. I would strongly advise that you take advantage of this situation. On Thursday, I will be assigning, I'm already standing here. I'm going to be assigning an assessment on Thursday. And of course, beginning this final exam review. But I want to make sure that you have this time. We have had this intervention period for I don't even know, a couple months now? I don't even know, dude. Definitely since spring break. But I want to make sure that you take advantage of it. So you have until 12:22. I am here to answer questions if need be. Please, let's be working on something that is needed for this class. Or if you're caught up on everything, then by all means, work on another class. But let's get going. Oh, I wrote those on the board. The one on the left we did before. The one on the right, I'm going to be talking a bit more on Thursday. But I'll leave that up there. I'll freeze it so I can turn my camera. There we go. That's not us. Yeah. You just have those on you? Okay.
Teachers, please excuse interruption. At this time, girls lacrosse team members will be excused. Please excuse the girls lacrosse team members. Thank you.
All right. Like I said, we'll be picking up with more of this on Thursday, where you will get that assessment for sequences and series, and we'll begin the final exam review. Email me if you have any questions. There is your bell.